Well, hello again, AP Calc. This video today is currently brought to you by Netflix as my children are watching a movie while I make this video for you all. So, I'm going to go ahead and apologize now because we're probably going to get interrupted. Alright, so continuing on with Chapter 4 and the theorems we are discussing. This video is going to focus on Rolle's theorem and the mean value theorem. Okay? Last video focused on the extreme value theorem, and so we're continuing on with these 3 theorems total, which will be enough for a quiz, not next class, but the class afterwards. So, let's start with Rolle's theorem. If f of x is continuous on the closed interval AB and differentiable on the open interval AB, and if f of A equals f of B, then there is at least one C on AB where f prime of C equals 0. So let's take a look at these couple graphs down here. Notice f of A equals f of B and what that looks like visually. 1. Could look just like this. Do you notice how, we have a horizontal tangent line. That means our derivative equals 0. At least one. We could have multiple. Or even the whole gosh darn thing could be horizontal. That line didn't line up. But you know what I meant. That's Rolle's theorem. So let's get into an example. Does Rolle's theorem apply? If so, find C. F of x equals x squared minus 3x plus 2 on the interval from 1 to 2. Oh, did you hear that? That's my youngest one coughing. Ugh, germs. Okay, so anyways, let's talk about our prerequisites. Are we continuous? Well, we're a quadratic, so check yes, we are. Are we differentiable? Well, let's take our derivative. F prime of x equals 2x. Yes, we are differentiable on our interval here also. Does f of 1 equal f of 2? Well, let's plug in 1. 1 minus 3 plus 2, that gives us 0. Let's plug in 2. 4 minus 6 plus 2 also equals 0. So check yes, our 3 prerequisites are met. Awesome. So what does that mean? Well, that means you are guaranteed some C such that f prime of C, I forgot my minus 3 here, f prime of C equals 0. So then we just have to solve for C, and we get 3 halves. And that is the C guaranteed by Rolle's theorem. Okay? Again, check to make sure your 3 prerequisites are met. Take your derivative, set it equal to 0. There we go. Example 2 coming at you. All right, now we have a quartic function. So again, we're here, and we're saying, okay, are we continuous? Check, yes, it's a polynomial, we are continuous. Are we differentiable? Well, let's take our derivative, and we get 4x cubed minus 4x. Again, domain of that guy's all real numbers. We are differentiable. So now I want to know, does f of negative 2 equal f of positive 2? Plug it in and check. Negative 2 to the 4th is 16. Negative 2 squared is 4. Times 2, 8. 16 minus 8, 8. Go again with positive 2. It also equals 8. Check yes, all 3 prerequisites are met. What does that mean? Well, again, our derivative, there exists some C such that our derivative equals 0. How do I solve this guy? Well, factor. Factor out the GCF. Left with C squared minus 1. Factoring that guy. C minus 1, C plus 1. And so we get that C equals 0, 1, and negative 1. Again, if you have any questions as we work through this video, please jot them down. We'll go over them when I see you next again in class. Okay? That right there wraps up Rolle's theorem. Recapping it, 3 prerequisites. continuous on the closed interval, differentiable on the open. Endpoints have to equal each other. F of A has to equal F of B, and then take your derivative, set it equal to 0, and solve. Okay? Moving on, we are now going to talk about the mean value theorem. This guy is a big one. It comes up a lot on the AP exam. The mean value theorem says, if f of x is continuous on our closed interval, differentiable on our open, then there exists at least one c on our open interval AB where f prime of c equals f of b minus f of a over b minus a. So what we're looking at here is visually, let's say we have that graph right there. So what that means is f of b minus f of a over b minus a. That's our good old-fashioned slope formula, the average rate of change, okay? Slope between 2 points. F prime of c is our instantaneous rate of change. So we're saying that somewhere, that is not a straight line, but you'll get the idea. Somewhere on our graph, the instantaneous rate of change equals the average rate of change. The slope of the secant line equals the slope of the tangent line. That's what we're getting at with the mean value theorem. Let's knock out an example. Verify that the mean value theorem applies. Find the c guaranteed by the mean value theorem. All right, we're starting with x squared. So, check your prerequisites. Are we continuous? Yes, we are. It's a quadratic. Are we differentiable? Well, what is f prime of x? That's 2x. So check, yes, we are. Then, the mean value theorem says that f prime of c equals f of b minus f of a over b minus a. Write down the formula. All right, that means 2c equals f of b. Plug in 1, we get 1. Plug in negative 2, we get 4. Over 1 minus negative 2. That means I have 2c equals negative 3 over positive 3. That's negative 1. Bringing it back up here for space. C equals negative 1 half. Again, what does that mean? Let's take a look at a quick visual here. In my quadratic of x squared, that means that if I have my 2 points at, we'll say, negative 2, let's go, there we go, positive 1, okay, so average rate of change, that right along there at negative 1 half, the average rate of change equals the instantaneous rate of change. Pretty awesome. All right, example 2. If you want to, pause the video, try the problem on your own, and then come back and check your work. And you're back. So let's keep going. So again, here, notice the interval we're looking at here from 0 to 1. We are, in fact, continuous, yes. Where did my pen go? All right, there we go. We are continuous. Check. We are differentiable. Yes, let's actually take the derivative here so we can discuss this differentiability. You get 2/3 x to the negative 1/3, which I recommend you rewrite 2 over 3 cube root of x. You might be looking at this function going, but hold please, Ms. Gutierrez, you can't divide by 0. To which I'm going to say, why, yes, you are 100% correct. Okay? But remember, it's differentiable on our open interval. And so the fact that that 0 here is an endpoint, we're not including it, we're totally okay. So again, what this means is f prime of c equals f of b minus f of a over b minus a. So here we go. That means 2 over 3 cube root of c equals, plug in 1, plug in 0 over 1 minus 0. So that means 2 over 3 cube root of c equals 1. Bringing it up here for space, I'm going to say that 2/3 equals the cube root of c. How do I undo cube rooting? Raise everything to third power, and we get that 8 over 27 equals c. Awesomeness. Let's do one more. Uno más. Here we go. Again, pause the video. Try it on your own. Come back and let's see what we get. Are we continuous? Yes. Yes, we are continuous. It is sine x. Are we differentiable? Yes, we are, because what's our derivative? Cosine. So again, what is our mean value theorem state? F prime of c equals f of b minus f of a over b minus a. Cosine c equals sine of pi minus the sine of 0 over pi minus 0. So cosine of c equals sine of pi. What is it? 0. Sine of 0. What is it? 0. 0 minus 0 divided by pi is 0. So then we have to solve for c, and I'm going to say, oh, it's pi over 2. And some of you might be going, Miss Gutierrez, it's also 3 pi over 2 and 5 pi over 2 and negative pi over 2. And I'm going to say, you are exactly right. But remember, we're only within 0 to pi. So our answer is just pi over 2. I want to rewind it slightly and go, wait a minute. My derivative is equal to 0 because sine of pi equals sine of 0. That sounds like familiar. Like something we did, I don't know, at the beginning of the video. Oh, hey, Roll, nice to see you again. Remember, okay, if f of a equals f of b, then there exists some c where our derivative is equal to 0. That's kind of cool. So Roll's theorem is just a special case of the mean value theorem. So remember, we've talked about 3 theorems so far: the EVT, the MVT, and Rolle's. Rolle's is just a special case of the mean value theorem that adds a third prerequisite, that f of a equals f of b. Alright, so what I want you to do now is tackle these problems on your homework, page 202, 204, numbers 1 to 13 odd. And we'll go over these together, recap these formulas, and you'll have a quiz 2 classes from now. Have a great day, guys. See ya.